Yes.
So I found out that I'm gonna be gone for the week before Thanksgiving.
Oh. I mean, of all the things, it's probably fine because
Is
it's
25th.
exam review. So.
Yeah. And then we were gonna stay down there a couple of days. Because we're gonna be in LA. So, you know.
Nationals for what?
Powerlifting.
Nationals. Okay. Whoops. So we're talking about our last transformation today. So this one is the equation sine of x minus pi over 8. So the purple one is the non-original. Green is original sine. What does it do?
It looks like it just moves it.
That is
Stretches. It's like a horizontal shift.
There you go. It's a horizontal shift. Did it go right or left?
Right.
It went to the right. How would we make it go to the left? We're gonna make it plus. So we know that those are opposite of what they feel like, right? There's plus pi over 8. Yeah, inside the parentheses thing. So the last one that we are talking about is the right left shift. Okay, so
You know what I meant by it.
Javon, I need you to stop talking, okay? So, I got Javon to stop talking. Now I need the rest of you to stop talking. Thank you. So we use different terminology here. So it's not a right-left shift. It's not a horizontal shift. It's called a phase shift. I told you that we borrow a lot of the terminology from science class. This is the thing. This is a thing that has a lot of application to sound waves. So even if you're like, I don't like science, I don't want to do anything with waves, here's an example. My husband is very much into, like, he really likes quality sound. He likes to listen to loud music. With surround sound in the upstairs and the downstairs. We have a home theater room. And so listen, it's super important where you place your speakers. Because if you place your speakers in a different place, you can have sound waves that are out of phase with each other. Okay, so when you talk about phase shift, like this all applies. If you have a sound wave that's doing one thing and it's shifted wrong with the other one, you can have warped sound or you can have sound that deadens each other because the waves kind of cancel each other out. This has application outside of science and potentially into your real life. When you talk about, I know you guys probably don't listen to radio very often, but that button in your car says AM and FM, right? Do you know what AM stands for? It stands for amplitude modulation. And so even though nobody wants to listen to AM radio because it's boring, the way that, just a minute. Hello. Do you have to do this immediately? Perfect, thanks. Bye. Eli, I need you in the athletic office later. Oh. No. So when you talk about, like, the way radio works is your radio station sends out sound waves. And so the way that you make it so that you don't get somebody else's sound waves is that you're assigned an amplitude, a specific AM amplitude on your sound waves. Okay, So when it says AM, each of those radio stations have different amplitudes that they're sending their radio waves on. FM stands for frequency modulation. Okay? Frequency is changing the period. How often does it cycle? And so radio technology has to absolutely do with this stuff. Do I know anything else about that? No, that's all I know. Anyway. Yeah.
What is your dad? What does your husband do?
He is youth pastor.
His wife pastor?
Yeah. We just save the money. That's all the things. Right? Just save your money.
Where at?
Yeah, where's he?
In Ravenna.
Holy cow, Weston!
That's a question.
What did he say? Weston?
Weston.
Don't repeat that, Weston.
Watch the recording.
So listen, we think home theater room. Don't think super exciting. We built it ourselves.
No, I'm asking
Right?
What church?
In Ravenna.
Oh,
Because that's where I live, you know?
fun.
Okay.
Great.
Anyway, like don't think about, listen, we have livestock barn. Leave us alone. Just kidding. Listen, don't think super exciting. Think we built it ourselves. It took 10 years, right? To get it the way you want it. So you can have things even on a teacher salary. You just have to put it up slow. Anyway, phase shift. So remember that it moves the opposite of the way that it looks. So if it's plus pi over 8, it's actually moving left. If it's minus pi over 8, it's moving to the right. Okay? So we need to talk about how do you graph this.
Think of like easy ones.
We're going to start with easy ones.
Interesting question. Well, like to the point where you can kind of line them up with the lines. Units.
What's this? What did you ask? That's an awful question.
Okay.
That's for you.
I'm not prepared for that.
I was very, very surprised.
Yeah, seriously.
Yikes. I apparently was not listening at the right point in time today.
Oh, it might be on the recording.
Oh, I'm going to go back on the recording and listen to see what awful thing Weston said. Okay, so we still care about the period of this. Okay, guys, I need you to focus. I don't have a lot of energy today, and it's going away fast, so
You want some pre-workout?
no, thank you. What's the period of this graph?
1.
No,
2 pi.
2 pi. 2 pi. Right? Because if we're going to change the period, that's the number in front of the theta, or the x, because x is a variable also. Theta is also a variable. Okay, so what's the amplitude?
1.
Yep. What's the vertical shift?
0.
0. Okay. What's our phase shift?
Right pi over 8.
Right. Pi over 8. Okay. So what you need to do, this is probably the one that's the most complex. It's not difficult. You just have to think a little bit. Okay. So we're moving. What I would recommend doing is putting your dots on for the normal graph of sine. Okay, like that. There's the graph, the normal graph of sine. Well, I would not connect them. You can, it doesn't matter. I personally don't connect them because it ends up being messy. So what you have to do is we have to move each of these dots right pi over 8. Okay, so that in and of itself is fine. You just have to figure out how much pi over 8 is. And the way that I would do that, you can't just slap a pi over 8 on there because it will mark you wrong if you're not relatively accurate. I want you to think about this. This is pi. This is half a pi. Right? Half a pi. Half of that would be what?
Pi over
A quarter of a pi, and so half of that would be pi over 4. So you kind of have to use your pi or whatever it is as a measuring stick to figure out. I would have to hit 8 things in there. So I'm thinking 8 pi is probably, would be if I divided this guy into 4. So 1, 2, 3. So 8 pi over 8 is probably about there. Okay, so what you need to do when you have a phase shift, you have to label the first shift, the one that's closest to the axis. But then what you do is you just go, oh, I'm moving it right that much. So then go that one, that one, that one, and that one. And then those are the lines, those are the dots, that you actually graph. So then your line looks like this. Okay, we'll do one that's a little bit, we'll see if we can get one that's just a little bit, let's see if I can make your life a little bit easier. Let's go cosine plus pi over 4. Okay, so cosine theta plus pi over 4. What's the period? 2 pi. What's the amplitude? 1. Vertical shift? Yep, 0 or none. What's a phase shift? Left pi over 4. So we know it's in the middle, it's in there, but it's opposite of what it looks. That's what your paper says. So because it's plus, we're moving left. The amplitude was 1, period is 2 pi. So if you're moving left, don't forget to leave space on your x-axis to actually move left. Okay, now I want you to think about this. Let me put my dots on for cosine. Give me 1 second. Cosine starts at its top. Okay, so think about the pi. We got to go pi over 4. Think of this as a measuring stick. This is pi over 4. This is half of that, which is pi over 2. So pi over 4 is going to be how much of this one? Half of it. So it's this much. I don't know how else to tell you. Like it's this much. So I'm going to go that to the left. So this is going to be negative pi over 4. Don't forget that it's negative because you're on the left side of the y-axis. So then you're just going to move them. This guy's going to go here. There, as you can see, the pi over 4. If you don't need to put the dots for cosine in, don't do it. But I personally like to because it helps me out. I have to think a little bit less. Okay, what questions do you have at this point? We're going to do a couple more because these are weird and they're about to get weirder.
I like it if we just catch it.
For sure. It's too easy.
No. As long as we don't be doing like change of the period, which I know we're gonna have to. As I say that.
Mm-hmm.
Trevor, shut up.
Trevor, why are you talking?
I know, but I can hear it in my ear. Like I'm trying to listen, and I literally can't.
Period before pi.
No.
Half pi.
How would you? Okay, so remember to find a period. That's on your paper. It's 2 pi divided by b. So what's the value of b here? 2. This is b. Oh, yeah. So the period is pi. Amplitude is what? Vertical shift? None. Phase shift?
Left, right, or pi over 4.
Right, pi over 4. I tried to make this one reasonable. When you graph it, you'll figure out why it's reasonable. So if all the way out is pi, what's half of that for the halfway point here? Pi over 2.
Oh.
Right? Because that's half of pi. Its maximum is 3. Its minimum is -3. Okay, normal sine. Put his dots in if you want. Okay, now pi over 4. This is why I told you this is a nice one. Pi over 4 is already marked, right? Because if this is pi over 2, that's half of that. This is pi over 4. You're welcome. So what happens is that every dot is moving one section to the right. So we're moving right pi over 4. So instead of 0 being there, 0 is going to go to the right. That would be there. And then that would be there. And then there would be another one. It looks like that.
Something went majorly wrong.
Let's.
I don't know. I'm just gonna draw a line. Oh, I think I have the wrong way.
You guys, we have to draw the parent function.
No.
No?
I don't draw the parent function. It gets too messy.
I was just gonna say, like, if we had to do it on like a quiz, we have to draw the parent function and show the.
Nope. It looked just like this.
That'd be rough.
It would be.
Why?
No, I don't want to make him.
She doesn't want to make a negative.
I don't want to make him negative.
Literally solve my problems. She's had 80 conversations.
Okay.
Talking now.
So hostile today. Oh, that's pi over 12, not 2.
Yep, that's pi over 12.
Oh. Pi over 12. Oh, wow, because the period is.
So I think what I would say when you're doing this is the last thing that you worry about when you're graphing this is the phase shift. So put everything on as if there was no phase shift, then deal with the phase shift. So he's the last thing that you do. Mm-hmm. It has to do with, I don't know. I don't know why it's called phase. It just is. What's the period of this? What's the period of the graph? Pi. What's the amplitude?
Oh, shoot, I shifted the wrong way.
So let's take care of that. Oh, pi over 2. There's my halves. 2 on the top, -2 on the bottom. Okay. Vertical shift? None. What's the phase shift? Left pi over 12. So let me see if I can give you one other way to talk about this. Like I said, imagine this as a ruler. If this is pi right here that I have on my graph, I'm just putting it here so it can draw all over it. This is pi over 2. If I'm talking about pi over 12, that's imagine like we're talking about the amount of space that would be if I put 12 divisions in there, right? So this is pi over 2. This is pi over 4. This would have to have 3 pieces in it like this. For me to have 12 divisions, which you don't have to do, but you have to think about, right? This would be the amount of space that I need to be moving my graph to the left. It's just a little smidge. Okay, so there's my regular cosine. And so my smidge is this much. Okay, that's what I've got there. So this is negative pi over 12. So 1, a smidge. Okay, there's my, oh, that's terrible. There's pi over 12 to the left. Okay, so you can put that, if you want to do your divisions right on your x-axis, you can. I don't, just because I don't, but you can. But that helps you see what you're doing. Like think about dividing the pi into 12 pieces. That's what you got going on. Now, questions on that? Because I got to talk about one more thing, and then I'm going to give you homework time. Okay.
I'm optimizing space right now.
Okay, we're not going to graph this one just because I would like to save us time, but we need to talk about it, and that does not mean that it's not important. We're just not going to graph it because you're going to get plenty of practice graphing. But I want to talk about period, amplitude, vertical shift, phase shift. Okay, so then this is the appropriate reaction. What's your question? Like, what's your thinking?
Why did we attach it to the
Right. Okay. So the way that if you look back at your other examples, the B is always separate from the theta in those ones. It's supposed to be. So it just means that this was distributed. And this is the way that you're more likely to see it because this is neater. It has less parentheses. So you have to reverse engineer this to figure out what your actual phase shift is. It is. Okay, so what's the period? That doesn't change. What's the period? What's the period? There you go, because this is B. What's the amplitude? 4. Vertical shift? Up to. Okay, so phase shift, you have to reverse engineer the fact that this should look like a 2 with the parentheses. And it's a division problem. You have to take this guy right here and you have to divide by whatever B is to get back to this. So it'd be plus pi divided by 2. So this is a phase shift what? Left pi over 2. Okay, so let's try a couple other ones. We don't even have to talk amplitude and vertical shift. I just want us to be able to separate these things because you have to do that to get it correctly graphed. No. Yes. I apologize. Yes, that's correct. Okay, so remember that when you reverse distribute something, I lost it, sorry. You're dividing. When you reverse distribute something, you're dividing. And so the math that you're doing is pi over 2 divided by 1/4. Well, you can keep switch flip. Okay, because we talk about that. So keep this, switch to multiplication, flip it over. This is 4 pi over 2. which is the 2 pi that Grayson said.
I just took the 4 and times by pi over 2.
Right? But do you know why you did it is the problem. Okay. So let's try,
Everything in the
okay. I'm really just looking for the phase shift on this. Okay, just remember, you got to divide by 4 because you want to pull that off. So you're doing pi over 6 divided by 4. Keep switch flip. Pi over 24, which is what Grayson said. Okay, so when we talk about keep switch flip, keep switch to multiplication. This is 4, which is 4 over 1. So 1/4. Keep switch flip.
When it's multiplication, you multiply the denominators. Right? Denominators on the bottom. Then when it's division, you multiply that number by the numerator.
Okay.
And then that's just
Okay.
part of the division.
So, you have a worksheet. I have a worksheet for you. This is
No, she's literally on my page. What do you mean normally I do? Well, when you say it. Connor, wake up.
just in case you want to know, what I generally shoot for is a maximum of 3 transformations per thing. Like, not likely to have you grab all 4. This gets to be a lot. Let's see. If you are Gold Star Club, you can cross off 1. Cross off number 1. Cross off number. Crap, I gotta tell you guys one more thing. 6. Yep. Okay. Pause a second. This is important and I forgot it. Take a look, for example, at number 4. Okay. Do you see, so number 4 is y equals 3 sine negative 4x plus pi. If you have a negative in the front, you have to pull that with the b. So in your division, the negative has to be pulled out with the b. So this has got to be negative 4 and then x what? Minus
5.
over 4. Okay, so then you have it b that is negative. Okay, so if there is a negative in there with the b, it has to be pulled out with the b also. Okay, so you want to do that. What was I tell you could take off? You can take off 2 also. 1, 2, 6.